This class notes video on how to use the Unit 5 study guide for fall 2020. Also, this is the exact format of your unit test. So the problems won't be the same numbers, but they will be the same type of problem. All right, so let's get started. So here's the test itself. And during the test, you're going to probably want to use your Mathway calculator for some of the problems and your Desmos graphing calculator for some of the problems. So we'll be switching to those during. This is one of the most important things right here that you have to remember in drop the base. All right, this is how you change between log and exponent, and going backwards, same thing. This is how you change between exponents and logs, okay? The log base and the exponent base. When we say the base, that's what we're talking about. And this is the log base, and that's the exponent base. All right. So the very first one we're going to do, convert to exponential. All right, so the very first one, we are going to drop the base. Let's do it in blue. All right, drop the base. We bring the x right here, and the 27 right here, and there's our answer, which is the answer right there. 27 equals 3x. Drop the base, drop the base. That's what you need to do for these. All right, when we studied exponential equations, this is an exponential equation. All right, there are two basic types of exponential equations. One looks like this, and it's a growth exponential equation. And the other one looks like this, okay? And this is a decay, all right? And you can tell the difference between a growth happens when this number right there, when b is greater than 1. Whatever number is right there, for instance, there is a 0.5 and there is a 2. Those are where the b is, all right? It's a decay when the number is less than 1, all right? And if the number is 1, then it's a flat line, not a curve, so we don't worry about that. All right, and so we will notice that A and B, that both of these are decay. All right, they're both decay because they are less than 1, because 0.5 is less than 1. All right, and over here, we have a growth equation, right? This is going up from left to right, so it is a growth equation. So neither one of those can work, all right? Now, the second thing is we learned about asymptotes, all right? Notice that this graph is really flat out here, right around y equals 1, right? So this is where y equals 1. And what we're going to see is that that growth curve will not touch y equals 1, and that's why it's called an asymptote. So this blue line right here is an asymptote, and it is at y equals 1. Well, right here in our equation, we can see that the k, this k right here, this k is the asymptote, all right? So we are looking for a growth equation with an asymptote of +1, and here's a growth equation with an asymptote of +1. Moving right along, expand the following algorithm. All right, so this algorithm is log 5, x squared on top, y to the cube, and z fourth on the bottom. Notice that it says that you need to focus on two things. One is that right here, this says when you are converting from division, you use subtraction. All right, so our answer should be subtraction. And notice that this answer is addition, So that can't be your answer. And this answer is also addition. So that can't be your answer. So these two answers both have subtraction. All right, so that checks. Now let's look at the other. Let's look at the other answer right here. And notice that the final step of this one is not done. Right, the final step would move this 2 over here and move this 3 over here and move this 4 over here. So this one, the final step is not finished, but this one does have the final step finished. All right, so that one won't work, and our answer is going to be D. So you could actually, knowing a little bit about what you do without actually having to go through all of the mechanisms, tells you that that's the answer. Let's go on to page 2. All right, page 2, let's go up to the top here. Hopefully I can see the top. All right. So this gives us a little reminder over here that the first thing we need to do when we're valuing these logs is move our exponent back over here. All right, so this says log 2 of, I'm going to go, so this of 2 to the 3 to the second power, we move that 2 over there, plus log 2 of 4 equals log 2 of n. All right, and so that's the first thing. Then the second thing is that, remember when we said on our last one, when we use subtraction, we change it to division. Well, when we add, we change it to multiplication. All right, so we are going to multiply these two. So they're adding right here. Well, we want to change that add to a times sign, and then we want to multiply. Oh, 3 squared over here is 9. So I'm going to change this to a 9, and 9 times 4. All right, so we have log 2 of 9 times 4 equals log 2 of n. All right, well, that tells us that basically we can, now that we just have a log 2 on both sides, we can cancel this out. So it says 36 equals n. Well, there's our answer right there. Now, you may not be comfortable with that, and you may want to check your answer before you're done. Oops, wrong one. And you may want to check your answer, and you can use your Desmos calculator to check your answer. So if we just put this in as 2 log 2, so maybe I'll just oops. 2 log, I don't think it's going to. Okay, this isn't a very good detail, but right here is a key. That's the log function, right? And so that's a log function that I'm using over here, just in case you're not sure where that key was. All right, so log 2 base 2, oops, wrong one. Okay, log base 2, and this is a 3. There we go. All right, and plus log base 2. These take a little while, the log problems to enter, and so I actually think it's faster to do it by hand. But you can definitely check your answer. Since this is a test, you do not want to put our numbers here. I'm just going to use an X here instead of an M. You can put n in if you want, but it'll still give me the right an answer. All right, and there, 36. So 36 turned out to be right. So it's you can use that to check your answers. It's a good mechanism for that. All right, so let's go back here to our. All right, so when we studied exponential functions, I gave you this fancy little chart here that shows you how to check things out. All right, so let's check this out. And I'm going to write right underneath it a little bigger, 3x plus 2 subtract 5. All right, so this says right here that k is the asymptote. All right, so this is our asymptote. K is equal to -5. And I'm going to look over here, and it says the function has an asymptote of -5. All right, so that is checked. That one works. All right. Second thing is we want to look at the 3. Okay, so the 3 tells us if the 3 is greater than 1, which it is, it tells us that it's a growth function. All right, so this tells us that it's a growth function. All right, and the very first one says this models a decay. So we know that's wrong. All right. Next thing is we need to figure out the y-intercept. All right, and up here it says the y-intercept is what you get when you put a 0 where x is, where x equals 0. So x equals 0. So I'm just going to change this x right here to a 0. And so we're going to get 3, 0 plus 2 minus 5. Well, that's 3 squared, which is 9. So 9 minus 5 is 4. All right. So y equals 4 is our y-intercept. All right. And so here is -4. So that one's not right. But here is +4. So that one's right. The last thing is has a range less than -5. Now, if you get confused about that, the easiest thing to do is go to your Desmos graph and put the function in. All right, so we have 3, and then we have 2. I don't know if you need to do this, but I have to put the 2 in first. Otherwise, it switches to the bottom and doesn't make it an exponent. And then, what was it, negative, subtract 5. Okay, right. Okay, yes, subtract 5. All right, and so, so back here, this said y is less than -5. All right, that was part of the answers. All right, so let's put that in. Let's put in this y is less than -5. Okay, notice that shades the area that's below the graph. That's not the graph, right? It should have said y is greater than -5, but it says less than, and so that's not right. Also, I want to point out that if you graph this, it will tell you what the y-intercept is just by tapping on the graph. It will show you what the y-intercept is. All right, which verifies that it's a 4. All right. So we'll go back to our. So that is wrong because it says less than. All right, so 3 and 4 were right. Well, here is our answer that 3 and 4 were true. All right. Solve the logarithmic function. Well, the first thing you want to do is add 7 to both sides, and that would make this side a +6. All right, so now we write it as log 2 of x plus 2 equals 6. We drop the base to bring this 6 down, and we get x plus 2. Then we subtract 2 from both sides, and we're going to get 2 to the 6th power. You can put that in your calculator, but I happen to know that that's 64. So we're going to get 64 minus 2, And that's going to give us a 62, which is right there. Let's check our answer before we commit to it. Go back to our Mapper calculator, and we're going to say log 2. Like I said, I think this is actually a little slower. X plus 2 subtract 7. Of course, you can be much faster putting this in there. Equals -1. And we hit enter. And it tells us the answer is 62. So, in fact, our calculation was good. All right. Moving on to the next one. Let's remember that when we have ln, all right, even though we don't write it, it has it's the base e. It has like the invisible e, right? So when you're over here and you drop the base here, like LE, you're not going to have a log, you're going to have a natural log, right? So this will say LN, all right? And then we cross this over, 19 equals 2x plus 1. All right, so we subtract 1 from both sides. So now this says log. You don't need to write the e. All right, so -1 equals 2x. All right, so when we subtract 1. Well, then the next thing I'm going to do is divide both sides by 2. All right, and that's what we get. And now I certainly cannot do that in my head. So I'm going to put that in my Mapper calculator. And see if I can remember it. It was natural log, so I'm not going to hit the other log. I'm going to hit this one right here. Natural log. All right. Natural log of 19 minus 1 and divided by 2. And hit enter. And so that's going to tell me the exact form, okay, in case I needed that. But this says 9722, 0.9722. And there's 0.9722 is our answer right there. All right. On to page 3. All right, which has the largest base? All right. Well, so remember the base is this guy right here, right? That's the base. All right. So this one obviously has a base that's equal to 2. How can we figure out the base of this table over here? Well, we know it's an exponential function because of the way it's growing over here. This is times 4. This is times 4. So these are all times 4, I notice. We get to one to the other. And so because you're multiplying each one by 4, that's really what this is going to be, right? So if you look at this 1, x to the 1 is equal to 4. Well, obviously that's a 4 because 4 to the 1 is equal to 4. And if we keep going down, x to the 2 equals 16. Well, that's 4 also. 4 squared is 16. So there's our base on this side. So our base is equal to 4. All right, that means that g of x has a higher base than f of x. So g of x has the largest base. And let's move on to our constructed responses here. All right, and now, so we have adding, all right, so adding becomes multiplication. Let's look at multiplication. All right, so we're going to multiply these, but the first thing we always want to do when we're dealing with these is move the exponent back. All right, so now this says log e of 5 to the third power plus log b of 3. And we're going to change addition to multiplication, just put a multiply sign there. 5 to the third is 125. So I'm going to put a 125 here, and I'm going to put a 3 here. All right, so we change from add to multiply, bring these two down, and that's 375. All right, so our answer is log b of 375. All right, and the same thing goes for our next one, except remembering that subtraction you go and do division. All right, so, but the first step is still the same. All right, so we want to move the space over here, right there. All right, and so now we have log b of 5. You don't need to rewrite this, I'm just doing it so you can make sure that you understand what I was doing. Well, 4 squared is equal to 16, right? Oops, I got my x. All right, now you change this to division, so we actually just put a line here, and the 5x is going to go on top, the numerator, and the 4 squared, which is actually 16, right? The 16 is going to go in the denominator. So there we are, log b of 5x over 16. Now you can check those by putting exactly that amount. See if I can remember this. 3 log, whoops. 3 log 5 plus. Okay, so you can put these exactly this way into your Mathway calculator to check your answers. And so this was 3 log b. This is much slower, but I've done. Can't even count the number of these I've done. So I'm pretty fast at this. And I'm also pretty confident about my answers because I've done so many of them. So, okay, so I put that in exactly that way. And then it asks me, what do you want me to do? This was we wanted to write as a single logarithm. That was our task. And then we have log b of 375, which was what we came up with over here. You can use the same thing, put the negative sign, do the subtraction, and it will give you, it'll say log b of 5x over 16. It may look like this. They may say it's 5/16 x, like that. But mathematically, that is the same answer. All right. Heading off to page 4. All right, so we have 4 problems on here, and we have to solve for x. All right. The first thing you need to do is you can't solve this problem when the base is different. All right, so you have to convert 27 to base 3. All right, now you might remember that 27 is equal to 3 times 3 times 3. Right, so we can say that 27 is equal to 3 to the 3rd power. All right, and so if we put that 27 instead, we say this is 3 to the 3rd power. All right, and we're going to multiply that 3 times the x plus 2. And then we're going to say 3 to the 5th over here. Okay, and so now we can solve it, okay? Now we can solve it. And so 3 to the 5th is, well, we don't really need to, let's keep going. So 3 to the 5th is equal to, now we're going to change this into, 3x plus 6. So I distributed the 3x plus 6. Well, since both of these are 3's, we can just look at it in that 3x plus 6. All right, so we're going to subtract 6 from both sides, and we get a -1 equals 3x. And then we divide both sides by 3, and we're going to get a -1/3 equals x. Okay, so there's our answer. If you want to check that one on Mathway, you can do that. You check all of these using Mathway, all 4 of these problems that I'm showing you. You can check on Mathway to see if my answer is right, and I encourage you to do that. All right, so we're going to use this little strategy right here by changing this to a log function. All right, so 3x minus 5 equals 5. All right, so we're going to drop the base. All right, so that's going to be our log base, and switch the numbers. Equals x minus 5. All right, so now I'm going to add 5 to both sides. So I get log 3 to the base 3 plus 5 equals x. Right now, so I actually have to go to my Mathway calculator and put that in log 3. All right, so we're going to say log base 3 of 5 and plus 5. And my calculator is going to tell me okay, so in exact form, that's what it is, but it's 6.465 rounded to thousandths. All right, so 6.465. I guess it's better to say x equals. All right, so there's our answer, x equals 6.465. All right, number 13, well, we've done a couple of these already. By converting these, the first thing we want to do is move that 2 right there. All right. And so now this says log of x squared plus log of 3 equals log of 27. Well, this is addition, so we change it to multiplication. All right, and so this is x squared times 3. And so this is log of x squared times 3 equals log of 27. Well, when it's just like this, you can't cancel the logs out, cannot cancel here. So you cannot cancel. Cannot cancel, and it looks like that. But when it looks like this with just a log on each side, you definitely can cancel this. So you get 3x squared equals 27 divided by 3. You get x squared equals 9. Square root both sides, you get x equals 3. All right. On our natural log here, all right, so the first thing we want to do is combine these, right? So these are multiplication, and we get x times, it's not as clear as I would like it to be. All right, so we get x times 3, so we change adding into multiplication equals 4. All right, so we get natural, and remember this has our invisible e here. So the natural log of 3x equals 4. We drop our base, All right, so E, cross our numbers, e to the fourth equals 3x. Divide both sides by 3, and that's our answer. E to the fourth over 3 equals x. We can write a decimal answer in here because E is just like pi. It has a value like pi does that goes on forever. And so we can actually put that in. So I'm going to put in E to the fourth power and divided by 3. I think it was divided by 3. I'll have to check later that just to make sure. Okay, and so it says it's 18.199. Was it divided by 3? Yes. Okay, so x equals 18.199. All right. And actually, if you wrote your answer like this, I would mark that correct also. Both of those answers are correct. All right, now we have a little word problem. Okay. This word problem says one person, since this is an exponential test, you know that these are going to be exponential equations. Okay. All right, so one person in town is a vampire. Yikes. All right, the number of vampires each week, the number of vampires doubles. Okay, well, doubling, so doubling is 2 to the x power, right? So because you get 2 times 2, and then you get 2 times 4, that equals 4, and then you get 2 times 4 equals 8, right? And then 2 times 8 equals 16. So this is your multiplying by 2 over and over again. All right, so it's 2 to the x is our function. So our function f of, well, they said use a t, so we better use a t. Okay, there's our function. And how many vampires will be there after 5 weeks? Well, t equals 5. All right, so we want 2 to the 5th power, and I have to know 2 to the 5th power, so we go to 32. So after 5 weeks, there will be 32 vampires. All right, how many weeks until the whole town becomes vampires? 600, right, was our, so when will our function equal 600? Okay, well, that's, so we drop the base, right? Get 2, so that log 2, and then cross these over. Log 2 of 600 equals t. All right, so I'm going to go find out what log 2 of 600 is. All right, so we have log 2 of 600. And MapWay says it is 9.23. Oops. MapWay says that t is equal to 9.23. So it says how many weeks? All right, so that's like, between 9 and 10 weeks, right? I think would be a good answer for that. The t equals 9 or 10 weeks. This doesn't really say how many weeks. Well, it takes more than 9. It lasts like 9 weeks in 1 day. You know, so, but either one of those answers would be good. All right. Now let's look at, you take a pain reliever, and the pain reliever loses 50% of its potency in your bloodstream every hour, loses 50%. Okay, so we have 100% and we lose 50%. So 50% is still left over. All right, so, and 50% we can also write as a decimal of 0.50. Okay, so that's going to be our function. All right, so we're going to have 0.50 to the x. Now, what's our starting value? All right, so we can't forget our starting value. In this case, it's 600. All right, up here we didn't write a starting value. Okay, we didn't write a starting value, but actually it's because it was a 1. All right, so our function really looked like this: 1 times 2 to the t, right, like that. All right, but we didn't really need to write the 1, so we simplified it to 2 to the t. All right, this one we can't simplify. All right, well, actually, this one is f of x. All right, and so that's our function. All right, so how much is remaining after 2 hours? Well, we want to make x is equal to 2, and so we're going to say 600 times 0.5 squared, okay, because it's 2. All right, let's go see from the math of calculator what it's equal to. So 600 parentheses 0.5 squared. And I think that's going to tell us it's 150. And it does tell us it's 150. All right, and so the amount remaining after, so the amount remaining is 150 milligrams. All right. And when will there be 100 left? Okay, so when will 600, when will our function equal 100? Okay, so the first thing we have to do is divide both sides by 600. All right, and that's actually 1/6. I'm going to write this over here so it's a little easier to follow. So we have 0.5x equals 1/6. All right, so we're going to drop our base. So our base is 0.5. So we have 0.5. Okay, so we have our base, we drop our base, and then we switch our numbers. Okay, so we have x over here, and we have 1/6 over here. Well, I'm really glad I have a calculator for this. All right, so we are going to have our log, and our base is 0.5, and it's 1/6. That's, and it tells me it's 2.585 rounded to. Well, during which hour? So it doesn't really matter. So x equals, 2.58, dot, dot, dot. And so it's during what hour? So it's sometime in the second hour, after like 2.5 hours, right, would be a good answer for that. So in about 2.5 hours. Two and a half hours. Okay. All right. So those are the word problems. All right. This one we're going to do the same thing. So we're going to do these side by side. All right. And so let's remember that the growth functions look like this, right? And this one's a growth function because this number is greater than 1. All right, so we're going to call this a growth function. All right, and this is less than 1, so this is going to be decay. And its graph is going to look like that. All right. Next thing is the asymptote. Well, the asymptote is that number right there. All right, we call that the k value, right? And that's a y, so it's y equals -4 over here and y equals -2 over there. And then the y-intercept. Okay, the y-intercept is when x equals 0. All right, so let's rewrite this with x is equal to 0. 3, 0 plus 2 minus 4. And that gives us 3 squared minus 4, which is equal to 5. All right, so that's our y-intercept is 5. All right, and over here, we're going to do the same thing. X is equal to 0. So we're going to write this as 0.5 to the 0 minus 2 minus 2. All right, and that's going to give us 0.5 squared. So let me write this a little clearer because we don't want to lose our negative number here. All right, so this is 0.5 to the 0 minus 2, minus 2, which is the same as 0.5 to the -2 minus 2. Now you definitely want to put that in your math calculator. Now, there's a way to do it without a calculator, but since we have a calculator, why not use it? Right, so to the -2, don't forget that it's a -2. All right, and then you're going to subtract 2 from that. All right, and you're going to find out that our answer is a +2. All right, so that is going to equal 2. All right. All right, now we need to graph these. All right. And so to graph them, we're going to use our asymptote and our y-intercept to graph these. All right, so first is our asymptote is -4. All right, so I don't have to do this in red, but I'm going to. So right here is our asymptote, -4 for this one. All right, and then on this side, our asymptote is -2. Right, so that's our asymptote on that side. Right, so our graph is going to approach that. Next thing we need is our y-intercept. Okay, so our y-intercept, I'll do that in blue. So our y-intercept here is 5, right? That's our y-intercept. So that means it's going to be 1, 2, 3, 4, 5. That's going to be right here. All right. And over here, our y-intercept is going to be 2, or +2. All right. So now remember, when it's a growth function, it's going to go like this, right? And somewhere along there, it hits the y-intercept. That's your y-intercept. And somewhere along here, this one hits your y-intercept, right? So that's your y-intercept right there. All right. So that means this one is going to look, is going to start here and go like that. Maybe your line will look better. And this one is the kind of the opposite. It's going to start here and go down like that. All right. Now, if you want to check those just to be sure, you can use your Desmos calculator for that. And that's what we're going to do right now. We're going to use our Desmos graphing calculator. You can see if you did that correctly. Oh, gee, the last one we did is almost the same. So let's just change this to a 4. All right. And there we go. Well, their drawing is much nicer than mine, but we can see that, yeah, that was the deal. right? So that it started down here. I guess I can fix this a little bit. Make it nicer. It started down here. I really can't fix it. It's hard for me to draw this with a tablet because I'm standing up while I'm doing this. Okay. Over this line. All right, and so there's our line right there. Going up. All right, and let's try our other one just to grab that, and it was 0.5 to the x minus 2, 5. Oh, 2 on the show, there we go. X minus 2, and it's going to have an asymptotic -2. All right, and okay, and there's that graph. So again, 9 doesn't look as pretty as there, so I'll try and change it a little bit, see if I can do a better job this time. All right, good. I'm going to go with this. Oh, that was pretty good. Okay. All right, and that was our last problem. So that's our study guide, and also you can use this video as a little bit of a tutorial when you're doing your test.